Hi friends, today we are going to talk about inductors. First of all, the question: what is inductor? Explain the different types of inductors. The definition of the inductor. Inductor is a passive electronic component which stores energy in the form of a magnetic field. A inductor, also called a coil, choke, or a reactor. It means an inductor is called a passive electronic component because it does not generate energy but instead stores energy. It stores this energy in the form of a magnetic field. This happens when electric current flows through the coil or inductor. According to Faraday's law of electromagnetic induction, a changing current through the inductor produces a changing magnetic field, which in turn induces a voltage or electromotive force that opposes the change in current. That is Lenz's law. The final explanation: an inductor is a passive electronic component that stores energy in the form of a magnetic field when current flows through it. In simple words, an inductor consists of just a wire loop or coil that is used to control electric spikes by temporarily storing energy and then releasing it back into the circuit through an electromagnetic field. It means an inductor consists of just a wire loop or coil. An inductor is made by winding wire into a loop or spiral shape. It does not have any moving parts, just a wire that is used to control electric spikes. It helps in reducing sudden changes in electric current called spikes. These spikes can damage circuits, so the inductor protects them. The inductor stores electrical energy but only for a short time. When the current drops or changes, the inductor sends the stored energy back to keep the flow smooth. The inductor stores energy in the form of a magnetic field created around the coil when current flows through it. In short explanation, an inductor is just a coil of wire, usually made by winding a wire into loops. It stores energy as a magnetic field. It consists sudden current changes means spikes by slowly releasing energy. Inductance is directly proportional to the number of turns in the coil. It also depends on other things such as the radius of the coil and the type of material around which the coil is wound. It means inductance is directly proportional to the number of turns in the coil. Inductance is a property of a coil that measures how well it can store energy in a magnetic field. When the number of turns in the coil increases, more magnetic field is produced for the same current. Therefore, more turns means higher inductance. Example, a coil with 100 turns has more inductance than a coil with 50 turns. It also depends on other things such as the radius of the coil. The radius or size of the coil affects the area through which the magnetic field lines pass. A larger radius means a larger area, so more magnetic flux is created, resulting in higher inductance. Bigger coils can store more magnetic energy, so inductance increases with radius. The type of material around which the coil is wound. This refers to the core material inside the coil. If the coil is wound around air, it has less inductance. If it is wound around magnetic materials like iron or ferrite, these increase the magnetic field strength and thus increase inductance. Magnetic core materials boost inductance compared to non-magnetic cores like air. In simple explanation, inductance increases when number of turns increases, radius of the coil increases, and the coil is wound around a magnetic material like iron. Inductor is made of a wire whose property is inductance. That is, it opposes the flow of current. It means an inductor is a simple electronic component. It is usually made by winding a wire into a coil or loop. The key property of this coiled wire is called inductance. Inductance is the ability to store energy in a magnetic field when current flows through the coil. It opposes the flow of current. This means that an inductor resists sudden changes in current. It doesn't block current completely like a resistor. Instead, when current starts increasing, the inductor opposes it by creating a magnetic field. When current decreases, the inductor tries to keep it flowing by collapsing its magnetic field and releasing energy. This opposition to changes in current is due to Lenz's law. In simple words, an inductor is a coil of wire that creates a magnetic field when current flows through it. This magnetic field resists any sudden change in current, which is why we say it opposes the flow of current. More accurately, it opposes changes in current. The inductance of the wire increases when the number of turns is increased. It means inductance is the ability of a coil or wire to store energy in a magnetic field when electric current flows through it. When you coil the wire more times, that is, increase the number of turns, you create a stronger magnetic field. More turns mean that each loop adds its own magnetic field. These fields combine and become stronger overall. A stronger magnetic field means more energy stored, which means higher inductance. The final explanation: more turns means stronger magnetic field. That is more energy stored. That means higher inductance. That's why increasing the number of turns in a coil increases its inductance. Inductance is represented by the alphabet L and it is measured in Henry. It means inductance is represented by the alphabet L. In physics and electrical engineering, inductance is symbolized by the letter L. The letter L is used to honor the scientist Heinrich Lenz, who formulated Lenz's law, which relates to how inductors resist changes in current. The unit of inductance is called the Henry. This unit is named after Joseph Henry, an American scientist who discovered electromagnetic induction around the same time as Faraday. 1 Henry means an inductor has an inductance of 1 Henry. It a change of 1 ampere per second in current causes 1 volt to be induced across it. The final explanation: symbol of inductance is L. Unit of measurement Henry. H. Named in honor of scientist L for Lenz and Henry for Joseph Henry. The formula of inductance can be given by the ratio of flux and the current in the circuit. This means inductance is calculated by dividing the magnetic flux linked with the coil by the current flowing through it. It is represented as L equals to pi divided by I, where L represents the inductance measured in Henry. Pi represents the magnetic flux linked with the coil measured in Weber. I represents the current in the coil measured in amperes. Simple explanation of the formula: magnetic flux pi is the total magnetic field that passes through all the turns of the coil. When current flows through the coil, it creates a magnetic field. The amount of magnetic field linked to each turn increases with more current. The inductance tells you how much flux is produced per unit of current. So, the formula means Inductance that equals to magnetic flux by current, or how much magnetic field is produced for a given amount of current. This formula is mostly used in ideal cases like uniform coils, and it helps understand how inductance relates to magnetic field and current. Next, let us discuss the inductor unit. Unit of inductance is 1 Henry. The unit is symbolized by the letter H. It means unit of inductance is 1 Henry. Inductance is the property of an inductor that tells us how much it resists changes in current by storing energy in a magnetic field. The SI unit means Standard International Unit used to measure inductance is called the Henry. We write it as 1 Henry means 1 H. The unit is symbolized by the letter H. In formulas and calculations, the unit Henry is represented using the symbol H. For example, L equals to 2H means the inductance is 2 Henry. The final explanation is the unit of inductance is called the Henry. It is written as H. It tells how much magnetic field is created for a given electric current change. An inductor is a passive electronic component that is most often used to store energy in the form of a magnetic field. In simpler terms, an inductor is a passive electronic component. An inductor is a basic electrical device made from a coil of wire. It is called passive because it does not produce energy, it only stores or resists it. The main function of an inductor is to store energy temporarily. It stores energy when current flows through it. Unlike a capacitor which stores energy as electric charge, an inductor stores energy as a magnetic field around its coil. This magnetic field is created when electric current flows through the coil. The final explanation: an inductor is a passive component that stores energy as a magnetic field when current flows through it. It is commonly used in power supplies, filters, and transformers. This is a measure of amount of energy stored in an inductor, which depends on the amount of inductance. It means this is a measure of the amount of energy stored in an inductor. An inductor can store energy when current flows through it. The energy is stored in the form of a magnetic field around the coil. This sentence is referring to how much energy is stored, which depends on the amount of inductance. The amount of energy stored depends on the inductance of the inductor, the current flowing through it. Higher inductance means the inductor can store more energy for the same current. Formula for energy stored in a inductor: E equals to of Li square, where E equals to energy measured in joules. L represents the inductance measured in Henry. I represents current measured in amperes. The final summary: the energy stored in an inductor depends on its inductance. More inductance means more energy stored for the same current. Let us discuss the inductor symbol. In circuit diagrams, an inductor is represented by a coil or loops. It means a circuit diagram is a simplified drawing that shows how components like resistors, capacitors, and inductors are connected in an electrical circuit. The symbol used for an inductor in circuit diagrams is a series of curved or looped lines like this. These loops represent the wire coil that makes up a real inductor. In American symbols, It's usually shown as curved loops. In European symbols, it may appear as a rectangle or a straight line with bumps. The final explanation: in circuit diagrams, an inductor is shown using a symbol with loops or coils because it physically looks like a wire wound into a coil, which is how it stores magnetic energy. It typically looks like a series of several closely spaced loops or a coil of wire, often with two terminals as shown below. It means this describes the physical appearance of an inductor. In real life, an inductor is made by winding a wire into tight loops like a spring or spiral. These closely spaced loops help create a strong magnetic field when current flows through the wire. An inductor usually has two terminals, mean ends of the wire. These terminals are used to connect the inductor into a circuit. This part suggests these would be a diagram or image of an inductor. A real world image of a coil with two wire ends. The final explanation: an inductor often looks like a coil of wire made of closely spaced loops with two ends for connecting to a circuit. This design helps it store energy in a magnetic field. The ends of the symbol normally indicate the terminals where an inductor can be connected to a circuit. In simple terms, in circuit diagrams, an inductor is shown as a symbol, usually a coil or a set of curved lines. This symbol has two ends. These two ends of the symbol represent the two physical terminals, that is, wire ends of the actual inductor. Terminals are the points where the inductor connects to other parts of the circuit. The inductor is connected into the electrical circuit at these two terminals. Current flows into one terminal and out through the other, allowing the inductor to function, store energy, oppose changes in current. The final explanation: The ends of the inductor symbol in a circuit diagram represent the real life connection points, means terminals where the inductor is attached to a circuit. These allow current to flow through the coil and create a magnetic field. This is the standard symbol of an inductor used in circuit diagrams, where curved loops in the middle. These loops represent the coil of wire in a real inductor. The number of loops is symbolic, not exact, just to show that it's a coiled wire, where two ends or terminals. The dots or circles at both ends represents the connection points or terminals. These are where the inductor is connected to the rest of the circuit. Current flows into one terminal and out the other, passing through the coil. The symbol shows that this component stores energy in the form of a magnetic field, opposes sudden changes in current flowing through it, and is a passive component. It does not produce energy, only stores or resists it.